This is old electronics fan, and this is part 2, and okay, well, I've made some progress on this. Let me swing this around first, and let's see here. Now let's see what we can see. We've got this little resistor hiding down here that's been replaced. On this side, we've got these two resistors replaced. I had to make do with a used resistor way back in here. I opted to do that because this thing was very close to being accurate within the range of, I think it was a 2%er. I don't see, that's supposed to be a 560. Do I still have that one kicking around? Yeah, it's a gold, so it's 5%. And so I think that's very close to being within tolerance. So let's see. I've got these two resistors here, and I think I quickly checked them. They're low ohms, and they're in the audio circuit, I believe. I'll have to look at that, but that's for another time. So this is the audio. This is the volume control for the audio, and this has to do with whether you're modulating your RF signal or not. I believe that's what that's for. I've checked this capacitor that's hiding down here. It's not bad. It's not in a mission critical circuit, so I'm going to leave that there. I've got these two resistors and this one, and they all test okay. I'm surprised at these, but they're close enough, so I think those are okay. And let's see. Oh, I've checked this one. It tests out pretty good, and we're dealing with, is it going to tell me what we're dealing with? I think it's low volts. I think this is 25 volts or something. 20,000 microfarad, but low volts. So that one, where are you? Yeah, looks like 18 volts, thereabouts. And the DC out range is 2 to 17 volts, so there's not a lot of extra there, but it's still low voltage. 17 volts is the max there, it looks like, and that's no load. Alright, so no load, it's 17 volts. When you put it under load, it's going to be closer to 15. I think that's what the setting on the front panel says it's supposed to be. Now, this guy right here, I marked this just because I wanted to see what was what. And I clearly remember saying, as I was recording, this could be corroded. And I did a quick look at it, but I didn't use a strong flashlight, and I probably should have used maybe a magnifying glass to see how bad it is. Well, this is corroded. And this is the culprit for why my meter wasn't working sometimes. When I was working with this, I got this resistor here. I soldered it here instead of here. It's a mistake. I finally found it, but my meter still wasn't working, and I didn't know why. I did make a mistake. I had this wire unsoldered because I was going to take this wire out of the way and move this if I had to. I thought it was in the wrong place on the bottom end. It wasn't. But I forgot to solder this back on. So that was one reason why I didn't have a working meter, because this wire was unhooked. One of the things that I try to do, if I know that something was working before I worked on it, then I can be pretty confident that I've made a mistake somewhere in the course of working on it. And that was how I found this problem. Instead of tracing voltages to begin with, which I started to do, I said, wait a minute, that's dumb. Go back and check your work. And the end result was I found my problem. Then I found that problem. I still had issues. So, let's see, where are we at? We're on resistance, okay. Now, I don't know if this is going to... Alright, so it's working right now, and we're on times 1, and this is supposed to be 100. Yeah, so this is way off now. I've moved it. But here's the problem. Let me see if it will actually do what it was doing before. I'm going to move this back a little bit. Get you up here. My screwdriver. This is the one I need to use, maybe? Nope, that's not it. This one. Alright, so let's see what happens. Now, right now it's behaving itself, but what I'm going to do is I'm going to shut this off. I'm going to spray that control, because when I was playing with this earlier, this was going all the way to off. It was going all the way to off and then popping back up. So clearly there's a problem, and you know, I said that it's possible that that is corroded. So I'm going to hit this with some deoxit. Part of the reason why I got myself in trouble is that I was kind of making, how do I put it? I was making an assumption, which is a bad thing to do. And, well, and my assumption was, oh, it's wire wound. There shouldn't be any problem with that. And well, that was a mistake. Now, it doesn't look that bad, but here's what can happen. In fact, let me put that where it was, right there. Yeah. All right. So, where the wiper rests on the wire in your wire wound control, this thing was lying on its side, and the mice were, of course, using this as their toilet, and I believe stuff got in there and it collected behind the wiper, and that caused corrosion. Thankfully, it doesn't look like it's too bad. It could have been a whole lot worse. I don't think I can get in there and show you this. I'd like to, but yeah, I can't tell for sure. But we're going to find out in a minute just how good or bad it is. So I'm going to put this back where it belongs, or where it was. It doesn't necessarily belong there, but... And the other thing I want to do is I want to check, I want to remind myself of what the resistance is. And I'm using my newer meter because I think it's probably more accurate. I think it is anyway. Alright, so let's read this first and see what we've got. I think it's 99 and something. Let's see. Oh, 100.1, 100.0. So, that's very accurate, very precise. So, now what I'm going to do is we're going to try to get this. I think I chose that one because it seemed to be accurate. And look at that. Let me show you. Oh, all right. I marked this before I changed it because I wanted to know where it was originally. I'm reluctant to play with these kinds of settings because usually they're set by the factory, and yes, this is not a big deal here, but they're usually set by the factory, and it's usually a good idea to leave them there. And that's the other reason why I tend to not touch these, because I don't want to screw anything up, but marking this like this keeps you out of trouble. And it also tells me, was this out of calibration because of corrosion or just because it was out? When I put, after putting the new resistors in, that's right, dead on. After I put the new resistors in, this became a whole lot more accurate. If I go to, let's go here. Now we're going to see, I'm going to put this on 2 volts. I have a battery right here. This is like 15 point, what are you? Let's find out what we got here. It is going to be 1.58, so it's almost 1.6 volts. Alright, so I've got this on 2 volts, and hiding down here we got it on 2 volts, and let's see what we have here. Come on. And it's just past 1.5. So let's see. So 2, 4, 6, 8, 10. So this would be, so that would be So 2, so 0.2 would be 1.7, and then I measure this, and it's almost halfway between. So it's not dead on. If I go straight on, it's probably 1.5, 2 or 3, something like that. But that's pretty good for this thing. So that looks good. So the next thing I want to do is I want to dig out, what did I do? I put my transistors away. So the next thing I want to do is come on. I think, if I remember right, this goes in this way, and all right, let's see what happens here. Okay, so that's in. So we've got this on. So everything. So that's PNP. This is on signal. I think I've mentioned before, unless you're using a power transistor, you don't want to put it on power. You can damage it because the voltage will be too high. All right, so we're going to do this. And I see this move just a slightly bit. Let's go up here to leakage. Oh, I don't have anything. Oh, I know why. Let's go down here. Let's try that. There we go. Let's go to leakage. Leakage is fine. And now my beta is, before I was getting 70. Now I'm getting, well, let's see, that's 150. So maybe 120. Now that's off a little bit because my other 2 devices are saying that the beta is around 140. So it's a little bit off. I don't think any of the capacitors I've got in here are affecting this. So, I mean, it is what it is, but it's working. And at least it gives me an idea. It can tell me whether I'm leaking. Why are you doing that? All right. So if I do that, whoops, yeah. So when I it looks pretty close. Yeah, it's pretty close. So when I don't have this on, this goes up to 0. When I put it on leakage, Well, it's not doing much, okay. And then I go to beta. Alright, so, wow. Yeah, I think there's a spring missing, I think. That should be in there. But, so it's somewhere around 120 is what this is reading. So by changing those resistors, I definitely improved how well this works. So at this point, other than the fact that I don't have these wires, I'm going to have to find some, I have to order some new clip leads. I think at this point I've gotten everything sorted out. It actually works. It's not as accurate as my newer digital devices, but it works. And the voltage looks good. The X times 1 was great. Let me just see. I got 68K here. Let's go back to. My brain is working. All right. 68K. So I'm probably going to have to get 100, but. So this is an issue. It's very limited. X times 100 is the maximum it goes to. So let's see here. So, all right. Let's see what we have. And turn that on. And if I go here, it should drop. And 100. So let's see what we have here. So on this setting, the R times 10. So there's 5K. Actually, it's times 10, so it's 50K. It's just shy of 70K, and this is supposed to be 68K. So that's not terrible. I mean, it's drifting a little bit. So it's saying about 70. So it's not all that great. And if I go back here to this, and it's about the same thing. It's about 70K. So that's it. So I started out being kind of discouraged. I wound up. I knocked the guy down on what he was asking for this, and I kind of wished I'd knocked it down a bit more. And I probably should have, and I didn't. I was afraid to say no, but then I'd have to counteroffer, I guess. So I paid $60 for this with shipping, thereabouts. There was another one that I was looking to get because I thought this one was probably dead. Especially I was worried about this meter. But right now, this meter, the zero is staying pretty zeroed. So it, I think that I got that saved. I think I saved that. So anyway, to get the other one of these, it was going to cost me $70 with shipping. So so I said, well, if I'm going to do that, then I might as well fix this one, and I should try. I'm going to try to get the original manual and schematic from Beckman, and I contacted them. They're still around apparently, and told them what I had, and did they have a schematic to send me. I said, no, we don't have that, but we've got this manual which contains a schematic in it. I said, did I miss that? So I went back and looked at the file that I'd already downloaded, and it says manual with schematic. It says, really? So I looked in it, and sure enough. And yeah, it's small, but I could read it well enough, and there was lots of helpful information. The notes, I'm going to tell you again and again, read the notes. And I'm going to try to get in the habit of doing that, because there's stuff in here that will help a great deal when you're dealing with your schematic. The notes are important, and I keep forgetting to read them first. Because you get in here and you're starting to figure things out, and it's like, well, I don't know about that, and then you go over and read them. Oh, okay. One of the things they tell you in here is where the control is set to in the schematic. What setting were they using when they drew the schematic? And they tell you there. And so that gives you a good starting point for trying to figure out where the different settings are on here, and where you should look on your different wafers to find the connections that your setting is making. Okay, I want to show you a couple of things before. Now, let me think here how I want to put that. One of them had to do with the question about this right here. And I finally got smart and I looked up the name of this wire, because they mentioned it here that it is somewhere. No. Where is it? So it's called this wire is called Magnon, I believe. And I thought I saw it on here. Wire wound. Come on, where are you? Resistance wire. Oh, it's in the parts list, and I don't think I've got the. All right. Okay, the parts list. It's interesting. In this, they tell you that this is a resistance wire, because they've got the two numbers, the 29 and 38 are the two shunts, and they call it out here as resistance wire, and that's what it is. It's a combination of copper, magnesium, I think, and maybe nickel. I may have put that in another part of the video, I don't remember. What's really strange, and you may have seen it in the previous, there were two wires soldered here and they were sticking out, and they looked like they'd been soldered at one point and then unsoldered from something. So I don't see anywhere on this wire any hint that those wires were soldered to these wires. Those two wires that were sticking out here were soldered to these wires. But here's what I think now. This is old school, and that Magnon wire, however you spell it, is used for shunts in ammeters. And what it's for is, since you can't put that kind of current across your meter, you use these two resistances that once they heat up, they develop a resistance. These have a resistance once they're hot, and they allow a certain amount of voltage or current to flow through these wires, which then will provide the correct measurement voltages for the meter, and I believe it's for the 5 amp circuit. So that's the part of the answer. I still don't really know why those wires are there. And the guy was going to send me a picture, and I don't recall getting it from him. Maybe he forgot me. But as far as I'm concerned, I don't care. This wire broke. I just wrapped it back together. Will it work? Maybe, but now the resistance has changed. This got damaged somehow. It got pinched. And I don't know if that was an attempt to adjust the resistance. I really don't know. So anyway, so there's that. But here's the other thing. This is what I really want you to see, because if you're working on something like this, you are going to be in for a fun time. Let's see. All right. Bear with me there. All right. First I want to show you this. Each of these pairs of entries have to do with the front and back of the switch wafer. And you've got one F, which is the front, and you've got one rear, which is the rear of the front of this front wafer. And then they go 2 and 3. When I was troubleshooting some of the problems, trying to trace things down and try to figure out where the connections were being made and all that, this thing drove me crazy. Let me go back here. This is the rear. This is number 3. Look what this says right here. This says 1 through 12. 1 through 12. I'll show you why that's confusing when I get into this part. But if you count this, there are 12 connections here. There's 6 on one side of the wafer, and then there's 6 on that side. Seems okay so far. Look at this one. See the rivets poking out the back here? Those are these little fingers, but they're on the front side of this wafer. I counting this, the connection from the front and the connection from the rear. The total number of connections I have here is 22. At first I thought I was really losing my mind, that I wasn't counting correctly. And it doesn't help that some slots don't have anything in them. There are no connections in them, so they don't have these little rivets and connections on the board. It's just an empty hole for that. So I finally just said, well, I'm going to count them all the way around. What that means is this is for the rear. This is for the rear. All of these are the back side connections. And all of the ones that are just the rivets are the front side of the connections. When you look at the schematic, it says that this is a 12 and this is a 12. Well, this one is a 12. This one is not. Because there's only 10 of these. These with the little clips on the back, or the little connections on the back, there's only 10. I counted multiple times, and like I said, I finally got smart and I counted all of them. And I figured out that there are not 24 of these. There's 22. Now, does that make sense? Bear with me, I've got apparently an allergy, so... Alright, so here is 2F and 2R. Look at this. Right here, okay. These are all number 12. Sorry, keep drooping down. And let's see, so the rear, alright, so the rear, go to the rear, 2R. This can't be 12 because there aren't 12 connections here, but that's how they've labeled it. And these two are tied together. So, is that right? Yes. So this goes here and goes here. So it really should be 12 and 10. But they labeled it as 12. I don't know whose idea that was, but that gave me all kinds of grief. I ran into it here because I was trying to track down a mistake I'd made when wiring in new resistors. And I got to these and I said, well, those would be a good reference and I'll find where I am. Well, that's not. This, yes. So this is the rear. This is the same, this is designed the same way this is. So they have 12 listed here? No. In fact, I believe these are not 3, 4, 5, they're actually 2, 3, 4. I'm not going to bother counting. You can count for yourself if you get one of these. So, and I actually wound up starting off with the one that's labeled as 6, and because I could find this, I knew what it was, I knew what color it was, I knew where it was going. So I got this to here and I started looking at this. This is also not 6, I think it's 5. So it can drive you nuts unless you know how this is wired, because it's going to give you no end of grief if you're trying to match numbers with the schematic with that. So that was fun. Oh, shunts. Yeah, I think I already mentioned it. I'm not going to go back there. Shunts are a way of supplying the correct voltage to the meter of your device while not having to put a high current or a high voltage on the meter. That's my understanding. But anyway, so there's that. It took me a while to think about actually looking up that wire, and then that's how I found out. I think Wikipedia had it. So manganese, I think I said it was. So it's definitely kind of weird. And what's really also confusing is that this is shown up as an adjustable. And it is, I guess, and I tried soldering this, but it's discolored. So I think if I were going to try to solder something to this, I would have to sand this to get down through the oxidation on that wire, and then see if I can solder it. Because this is partially copper, in fact mostly copper, it's 80%. And 80% copper, 30% manganese, I think? I don't know. You can look it up. It's probably somewhere else in the video. I'm pretty sure I might have included that. But anyway. So having these wires that you could solder to this, I guess that's how you would adjust this to get the right resistance. But when I got this, these two wires were sticking up and they had solder on them, but they weren't soldered to anything. So that was definitely bizarre. Definitely left me guessing. So in any case, at this point I'm not worried about that. I'm not going to use the 5 amp or this. In fact, I probably won't use the ammeter part of this at all. I don't think I need to. I've got enough meters that are modern and much more accurate. So there's that. But I finally got this sorted out. I finally understand what's going on, and it took me a while to figure out what was going on with this, and I thought I would help others avoid having the same kind of fun with either this unit or something else that does the same sort of thing. So, you know, this is. Let me just zoom in here. This wire and this wire are soldered together. This is actually 10, and this is 12. But the schematic says it's 12 and 12. It's not. Not really, as I just pointed out to you. So, yeah, fun. And I think there are a few other things where they're soldered together, like this little resistor. There's a connection it makes here, and those are soldered together, and they're called out as the same number. They are not. So, anyway. Now I've got to show you this, and I'm really, really interested in somebody commenting on this, because let's see if I can get in here. Yeah, I don't know. Let's see. I'm going to try to get in as close as I can. And I'm going to see if I can explain this. Can I? Well, they drew this, both of these, as though there were 12 connections. There aren't. And where it gets really fun is that on, let's see, where is it? I think it's 12 and 12. Okay. This is the rear, this is the front. These two are tied together. And they identify them as being 12. Well, it depends on, but there aren't 12. I have the same problem here as I do here. One side is 12 and one side is 10. But they don't identify them that way. And I'm just, so well, let's go over here. 3, 4, 5? No. I think it's 2, 3, 4 is what I actually count. I was very confused, and I finally gave up, and I just simply said, well, I know this one comes in from there. I'm going to use that as a reference point, and that tells me where those are. I know where that is. I don't know what number you are. And when I was chasing down connections and stuff, I thought, well, I don't know what they're doing, but here's what I'm doing. So when you're working with this anyway, with the B and K, be aware of the fact that some of these numbers lie. Because, and I can understand what's going on, because, let's go back to this one for a minute. Oh dear, I really zoomed. Notice I've got these two, this is for the rear. Well, that means you're going to lose 2. So what's our total number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 of them there. But we have a problem. They're saying there are 12 on the front and there are 12 on the back. And there aren't. So 6 of these have to do with the rear, but 4 of these I think have to do with the front. So let's see, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. Oh, this one does actually have 6. It's got 12 total. Oh, actually, that makes sense. It's 12. It is 6 and 6. This one actually is right. The others, now, the total number of connections here is 12. The way they have it drawn, they make it look like you got 12 and 12, but you don't. The total number on here is 12. But 6 of these are one side and 6 of these are the other. On this one, it actually is right. On this one, I spent a whole lot of time counting, and I came up too short on one side. I forget. I think it was the rear side. And I counted multiple times. I'm pretty sure that, well, let's see. So there is 1, 2, 3, 4, 5, 6. All right. 1, 2, 3, 4, 5. Yeah, I'm right. So, so this one has got 10 and 12, and this one I think has 10 and 12. This one has 6 and 6. Front and 6 front, 6 back. So when you're working on something like this, you got to be aware that the schematic and the actual equipment, they don't match. Okay, I was going to just wrap up, but I changed my mind because there were things that I wanted to do. Put the BNC port on there. When I was putting these wires on here, I mean, this was, I gotta unplug this so I don't get bit. Well, when I was putting these wires on here and running them, I discovered that that resistor was bad. I had to put two together because that was way out of whack. Was there another one? I don't see it. This one was way, way off. That was definitely off. I thought there was one more and I can't see it. Anyway, so I put those in, ran these new wires in, and I double checked everything. I'm going to try hooking these up to this in a minute, make sure that this is wired up correctly. So that resistor was good, that one was, that one was, that one was, so was that one, and that one needs to be replaced. And maybe I will at some point. I don't know if I might have one of those. I don't know about these, but I got to show you this because that made a difference. Just, I thought there was another resistor somewhere that I needed to change, but regardless, let me just show you. All right. Well, let's see. Okay, I guess. And all right. Turn this on. I'm going to put this on leak. Nothing. And I do this. Looky, looky. That is all right. So this is 200. That's 100. This is reading about 140, and that's in line with one of my my Radio Shack tester, and I think the other one was nope, it just jumped up a little bit. It's wiggling around. That's interesting. Do I have a flaky connection? I don't know. So anyway, this is now reading closer to where it's supposed to be. 47 is what one other meter read, and this is very close to that. So I think this is now working really well. Let's see. Oh yes. So this is for fun. Let's see if this works. All right. And yep. So that works. Oh, I'm sorry. So I had this hooked up to this, and as you saw, it's reading the same as this was. So, yeah, I gotta get some new clips. These are, I don't know if the problem, part of the problem is these rubber or plastic parts, they're very tight. Maybe I should just get rid of those and just hook them up. That one looks okay, kind of. And this one, that one looks decent. Let's check it out here. Oh, yeah. There's a gap. If I go this way. There's a gap there. That might work. All I do is twist the end of it. Maybe that will be better. That might have fixed it. Oh, come on. Well, yeah, well, kind of. Well, these clips actually came off my Alenco transistor diode tester. I decided I want to use different ends on that, and I think I want to change those ends because I'm not crazy about those. Well, that might work well enough. Just have to make sure. Just by twisting the end of this, it improved it greatly. Anyway, so where was I going? I don't know. All right, so yes. So I think by replacing those resistors, however many I replaced, and these are the ones, these are all the resistors that are replaced in this. And some of them were way off, and some were just, they're outside of the specified percentage, the 2% or 5%, whatever they were supposed to be. They were outside that. So everything that wasn't in spec got replaced as far as the resistors, and that did make a big difference because this was at least 20 points off where it was supposed to be compared to some of my other tools. So I'm really happy with this now. It works. Oh, and I did straighten this out. It's not perfect, but it's not. It was curving in. It was curving that way, and there's a little bit of a dent in. I tried really hard not to do that, but there's a limit to what you can do. And if I really wanted to go crazy, I could try it. No, I can't. There's no place to get in behind there. So, oh, and the case, yes. I don't know if I showed you the case, but this, let me just back up a little. I mean, this, it's rusty. As you can see, rust. There's rust there, but I cleaned this with soap and water, and then I hit it with steel wool to try to get rid of leftover junk. So I think yeah, I mean, it's been around, let's put it that way. So it needs to have a paint job, which I might do once the weather warms up. I might take this and clean it, because I have something else I wanted to hit with. Oh yes, a radio. I want to do a crackle finish paint for it. So we'll see. I mean, it's not. I mean, what I don't like is that it's rusty, and I'd rather have it not continue to rust. And this is actually pitted, I think. So, but this doesn't have to look like brand new. But I think a little bit of paint would definitely benefit this a lot. So I got to round up screws because this came without any mounting screws. But I think it came out pretty well. I think it came out really well. It looks a whole lot better than when I got it. It works a whole lot better. Replacing all of the resistors that were out of spec. That made this thing work a whole lot better. So I am definitely going to yeah, let's see. I think that's it. I'm done. I think I'm going to insert this in the middle or somewhere toward the end of what I've already recorded, right before I actually do bail out. I'll have to find out when I edit it what I wind up doing here. So anyway, but it's done. So it's pretty much done, other than maybe painting it. That's about it. And I got to decide what I want to do about this. And I'm going to try to find some vintage banana plug, some banana jacks. If I could get this looking like it was originally, that'd be pretty neat. And if I have to, well, I can make these two look the same type. But anyway, well, I was thinking about wrapping up the video, but I remembered that there's another guy that has one of these, and he's troubleshooting this. And he says he's been using it for a long time, and he's trying to get rid of that. And he's thinking that there's a bad transistor in his unit. But I thought, well, I wonder about mine. I wonder if it's doing the same thing. And it's pretty much identical to what his output is. So it makes me wonder if that's just the way these things are made. And I had this hooked up to my, I think I did record that, my frequency counter, and it seems to be working quite well. And you can see, oops. If you go to, let's see, where am I going? Oops, I was going the wrong way. So it doesn't seem to matter what band you're on. You still have the same issues, same problems. So and this is a kind of a narrower band. So yeah, so I have a feeling he's not going to fix I don't think he's going to fix his problem by putting another transistor in there, because it looks like mine is doing the same exact thing. I mean, identical. So yeah, so shut that down for now. Get this out of the way for a minute. Oops, I go. Alright, well, I am wrapping this up. I did paint this. It didn't come out perfect, but with it being rusty and scratched and whatnot, I guess got some dust on it already. I think that'll have to do. Definitely looks a lot better than when I first got it. I see, actually I need to paint in there. I'm kind of wanting to this was supposed to be a lighter, it's supposed to be a gray, and all I could find was the black on you. So, but it's not terrible. It probably would look nicer if it were the lighter gray color than this, and I realized I didn't realize this would stick out that much, and that needs painting as well. What I might do is I might put it up on the shelf and see how much I use it, and see if I can get some use out of it. It'd be nice having all of this available all in one device. That's kind of what's nice about this. And who knows, I mean, I could put this up and take that one, put it somewhere else unless I need it in a range that, let's see, okay, 800, yeah. So this would be AM, this would be FM, and 08. Let's see, I'm looking at this. So this looks like this has okay. Well, anyway, yeah. So I think this would work. So 250 to 800, 800, 2000. So that's the AM part. This is apparently the FM part, and oh, actually, that's saying AM there. This is FM, but usually FM is, well, 10 to 8.4, and it's usually 10.4. And so that one is 2, I would think. So, I'll have to look into that. That's, I'm always learning something new, and I didn't look at that very closely. I do have the manual for this, and that will tell me more about that, I think. So, yeah, so I think, yeah, it's all working. I've got paint on the outside to deal with the rust, and given what caused the rust, even though I cleaned it, I decided that I really wanted to sand it down, and then I can see where this textured paint could be a good source of dust, or make a good dust collector. Anyway, so I guess what's going to happen is, yeah, so I wanted the rust, and anything that, even though I'd cleaned it, I wanted it off, I wanted it gone, I wanted this to be maybe a little bit cleaner, so the paint will accomplish that. And yeah, I did sand it down pretty good, because there was a lot of hidden rust when I was just scrubbing it to see, knock down. I was starting off just by knocking down the paint to rough it up a little bit so the paint would stick, and I was surprised how much rust there really was on that. I it shouldn't have been, I guess, given the fact that it was a mouse trail, apparently, wherever it was. But anyway, so I'm wrapping this up. I'm hoping that you enjoyed this, and that that you maybe got some information that was of value. I hope you enjoyed the repair work I did on this. It definitely challenged me a bit. It was disappointing, and one of the things, okay, I know I said I'm closely wrapping up here, but let me do this. Let me say this first, before I close the reel. I learned something good about this right here. The wire wound control. Two things I learned. Number one is you need to check the control itself and test it. Make your mark, make sure you know where it's adjusted to, and then check and see if it's behaving. Use your meter to do that. I made the mistake of not checking the wire wound potentiometer itself, but I also didn't, when I was testing this, putting a small voltage across this, I put it directly across the 2 posts that are on the back of the meter. What I should have done is I should have connected to this in such a way that the potentiometer was in the circuit. This side doesn't have, this side is, well, yeah, so there's a wire that comes up from the circuit board and goes to one side of the potentiometer. I should have connected my voltage to that wire, and then I could have connected the other side to the post on here. That would have given me more information than I was getting the way I was checking things out before. So live and learn, I guess. So I got lucky because I put voltage on this, and did I put it directly on the posts? I think I did. Whatever the reason, it started working again. Maybe it's because I jiggled it a little bit or hit it or something, and that potentiometer started to work. I got really lucky. Hopefully I would have thought about that and thought, hey, given how much stuff was going down into that potentiometer, maybe I should check that. It'd be an obvious thing to do, and I didn't do it. So wasn't thinking when it came to that, but the end result is great. This thing seems to work well, seems to be reasonably accurate. On this, actually, I might at some point play with this, because I had it connected to my universal counter up there, and it's a little bit off, and I think I can use the manual's instructions to adjust this to get it so it's closer to what it's supposed to be. And then if that works, then I could just use this without my counter, and it's just a simple directly wired connection. So that's something I might do. But I want to wrap this up now. I've got another project sitting in the wings that I want to finish up, or I want to get to, actually. And so, yeah, so by getting some paint on this, now I can put it to use, and I can move on. So, if you watched this far, thanks, and I hope to see you on the next one.